Folder 9, Middle Childhood Cognitive Development. Piaget suggested that children in middle childhood enter a cognitive stage of development characterized by concrete operations. These operations involve the processing of information about tangible and concrete objects rather than ideas. A major advancement in the child's cognitive development is characterized by reversibility. This newfound flexibility allows a child to do mathematical operations and to realize the relationship between things. This increase in flexible thinking also means the concrete operational child is less egocentric, meaning he or she can begin to take the perspective of others and to realize that not everyone views the world in exactly the same ways. Another important cognitive advancement is decentration. This allows concrete operational children to focus on multiple aspects of a problem at the same time. As you might guess, this increases the speed with which they can solve complex problems. Children begin to show an understanding of conservation, which involves both reversibility and a realization that objects can have multiple properties. A tall glass, for example, may hold less than a short glass because the short glass is wider. Concrete operational thought also involves an understanding of transitivity, the ability to compare multiple options and make a decision, and seriation, which involves setting things in order. Class inclusion is another ability of the concrete operational child. This ability includes an understanding of which objects belong to which category, which represents an understanding of the principles of assimilation and accommodation. Evaluations of Piaget's theories suggest that they are too limited. Part of the concern is that he may have underestimated children's abilities. The language used in some of Piaget's tasks may have been confusing for some of the children. Nonetheless, Piaget's work has been very influential and provides a very strong foundation on which to build research on cognitive development in children. Piaget was also very interested in children's moral reasoning, how they make judgments about whether something is right or wrong, and their understanding of rules in children's games. Piaget gave children moral dilemmas and observed them playing games, like marbles. Based on his observations and findings, Piaget believed children experienced two stages in moral development: moral realism, or object mortality, and autonomous morality. Moral reasoning begins around the age of 5. At this time, children tend to regard the rules as whatever an adult authority figure tells them. Children tend to judge how wrong an action is based on the amount of damage done, more than intentions. Children at this age also tend to believe in immanent justice, the concept that a wrong behavior and punishment are inevitably linked. Autonomous morality tends to emerge around 9 or 10 years of age. Rules now are based on group consensus rather than instructions from an authority figure. More importance is given to the intention of others. Greater role-taking ability probably facilitates these advancements. Lawrence Kohlberg also used moral dilemmas to study children's moral development. His most famous dilemma involves a man stealing a drug to save the life of his wife. Kohlberg was very interested in the kinds of reasons children gave for whether or not the man should have stolen the drug, and how these reasons tended to change with the age of the child. Kohlberg described 3 levels of moral development, with 2 stages embedded within each level. At the pre-conventional level, the child focuses on the consequences of their behavior for themselves, avoiding punishment and reaping as many rewards as one can. Children at the conventional level are more concerned with pleasing others and doing their duty, such as obeying the law. Conventional level thinking tends to emerge during middle childhood. Post-conventional level reasoning does not occur in a large number of adults, but it may emerge in adolescence. It involves the understanding that laws only represent agreements necessary for the survival of society and may need to be changed. In addition, individuals may have self-chosen ethical principles that may take precedence over any law. Piaget considered children to be small scientists. Those operating from the information processing approach view children as computer systems. The computer metaphor may examine how children store, retrieve, and process information. Key aspects of information processing include 1. Development of selective attention. 2. Development of the capacity to store and retrieve information. And 3. Development of strategies for processing information. Information processing theories focus on the capacities of three types of memory structures: sensory memory, sometimes called the sensory register, working memory, and long-term memory. Some of the research done on information processing confirms Piaget's observations about children. Young children may not be able to conserve, for example, because they have difficulty paying attention to multiple aspects of the problem. Thoughts about how humans store and retrieve information have led to advancements in our understanding of memory. Researching shows, for example, that auditory stimuli can be maintained longer in working memory than visual information. It would be wise, then, to assist children in encoding information auditorily to enhance memory. As a child gets older, he or she will experience an increase in the number of chunks of information that can be held in working memory. The average adult, for example, can hold about 7 chunks of information in working memory, while the average 5-year-old can only hold 2 chunks of information in working memory. While children can learn new material through rote learning, repeating something many times, a more effective elaborative strategy is to relate the new material to information that is already learned. Making new information meaningful, creating semantic code, is the essence of this strategy. As children learn more and more, the information in their long-term memories become more organized into categories. Information processing theorists look at children's awareness of and control over their own cognitive processes and memory. Children's awareness of their cognitive processes is referred to as metacognition, while their understanding of how their memories work is referred to as metamemory. One example of how a child might use this knowledge and awareness involves selective rehearsal, in which the child improves memory by excluding and therefore not memorizing unimportant information. Generally, achievement refers to what a child knows or has learned, whereas intelligence refers to a child's underlying competence or learning ability. Although original theories of intelligence tended to consider intelligence something that some people had more of than others, contemporary theories look at intelligence as a set of factors. What this means is that people could be more intelligent than others on certain factors, but less intelligent than others on other factors. In these kinds of approaches, a statistical procedure called factor analysis is used to try to determine the most important factors of intelligence. Many theories assume that there are primary mental abilities, such as the theory proposed by Thurstone, and differ on what other specific abilities there might be. More recently, Howard Gardner has proposed a theory of multiple intelligences. Although this theory concurs with other theories by proposing logical and problem-solving abilities, it also includes more unusual intelligence, like bodily kinesthetic, shown by gymnasts and dancers, for example, and interpersonal intelligence, defined as self-insight. A very recent theory was proposed by Robert Sternberg. This triarchic theory suggests that intelligence involves the 3 components of analytical, creative, and practical intelligences. Although there are disagreements about how to define intelligence, psychologists administer intelligence tests every day. The Stanford-Binet Intelligence Scale and the Wechsler Scales are the most widely used tests. Despite disagreements about how to define intelligence, these tests are administered so often because important academic decisions about children depend upon these scores. Children whose scores fall below certain levels may be placed into special classes or programs that are designed to provide them with different kinds of or enhanced assistance. Although there are good intentions, disagreements about the validity of the scores and the controversies surrounding the potential for racial or economic bias may prompt caution in how these test scores are used. Rathus, for example, suggests that it would be wise for the decisions to be made only after a battery of tests is given by a qualified psychologist, in consultation with parents and teachers. Intellectual development has been studied intensively. Research suggests that intellectual development is not linear and gradual. There are times of rapid intellectual development interspersed with more steady advancements. The first major spurt in intellectual development appears to occur at around age 6. This spurt coincides with the child going to school and is characterized by what Piaget describes as the shift from pre-operational to concrete operational thought. The second spurt occurs around age 10 or 11 and may precede the multiple physical and psychological changes of adolescence. Because of these spurts in intellectual development, IQ scores are probably less predictive for younger children. Once these spurts have occurred, one would expect there to be more consistency in how the child scores across time and in predicting what these scores might mean. Children who score significantly lower than other children for their age may be labeled as mentally retarded. The majority of children who are mentally retarded are mildly retarded. Children with Down syndrome are usually moderately retarded and can still learn to talk and take care of many daily needs such as dressing, feeding, and cleaning themselves. While some kinds of retardation are biological, cultural familial delays refers to a biologically normal child who has not received appropriate environmental stimulation. Gifted children are those who excel on standard tests of intelligence and/or who have had outstanding capabilities in specific areas. Socioeconomic and ethnic differences in IQ are controversial and complex topics. Poorer children tend to score lower on intelligence tests than children from more advantaged backgrounds. Since larger proportions of many minorities tend to be poorer, cultural and socioeconomic differences have at times been confused. Whether or not the traditional intelligence tests are culturally biased is another important issue. Recent IQ tests are designed to be culture-free. That is, the test items are not dependent on knowledge from a particular culture. Sternberg defines creativity as the ability to do things that are novel and useful. Although what constitutes creative may differ in the minds of different people, creative children are said to share a number of qualities. These include taking chances or doing things differently, refusing to accept limitations, appreciation for music and art, and challenging social norms or being nonconformists. Creative people may make associations that others do not make and may put elements together in novel ways. Much has been made about the relationship between creativity and intelligence. Certainly, some theorists consider creativity to be a type of intelligence. Sternberg considers it one of three types of intelligence. Others, however, suggest that the relationship between the two is modest at best. Perhaps it is best described by delineating convergent thinking from divergent thinking. Convergent thinking involves narrowing down the facts to find the best solution to a problem. This would be a necessary ability for traditional intelligence tests. But creativity involves divergent thinking. This type of thinking involves free association that is not limited to facts. A creative child appears able to make many associations from a single piece of information, while less creative children see things more simply, or at least within stricter limits. Both genetics and the environment influence intelligence. The question is not whether each has an influence, but one of how much. Kinship studies look at the correlations between the IQ scores of persons differing in the degree of genetic and environmental similarity. Identical twins, for example, share complete genetic similarities, while other siblings share less. By looking at twins and other siblings reared together and reared apart, such studies can begin to document how much intelligence is influenced by genetics and the environment. If, for example, the correlation between IQ scores of identical twins reared together is 0.85, and between identical twins reared apart is 0.67, then we can claim with some degree of certainty that genetics plays a strong role, but environment does too. Research suggests that heritability of intelligence is between 40 and 60%. In other words, over half of the variation in IQ scores can be explained by heredity. So about half of the difference between your IQ score and the scores of other people can be explained by genetics. With that being said, environmental influences are important. Even the immediate environment, such as a testing situation, can affect outcomes. When an examiner is friendly and warm and makes sure that children understand the directions, test anxiety is reduced and IQ scores increase. Also, stereotype vulnerability, making one group membership such as ethnicity salient, can also affect test scores. Evidence from orphanages and adopted children studies also support the role of long-term deprivation versus stimulation. It may shock the reader to discover that the typical 6-year-old already has a vocabulary of 10,000 words. Children quickly learn grammar, which delineates the rules for how words can be combined. Children move from having difficulty understanding passive sentences to processing them as easily as active sentences. Language development, of course, is a necessary precursor to the development of reading skills. Neurological maturation and experience combine to allow children to make the fine discriminations between letters necessary for reading. Word recognition methods of reading teach the child to recognize what words look like and how to say them. So the child must remember what the word cat looks like in order to read. Sight vocabulary is a term used to describe the collection of words a child can immediately recognize based on familiarity with the word's overall shapes. Phonetic methods, on the other hand, teach the child to read by teaching them how to associate certain combinations of letters with the sounds they make. Although it may seem to most of us that learning a second language is quite difficult, research appears to contradict this assumption. Most people throughout the world are bilingual. The exception, of course, is North Americans. Some research shows that being bilingual contributes to the complexity of the child's cognitive processes.